There are loads of dams on the Colorado River that generate so much power that millions of people in 7 states don't need to worry about their TV, computer, or any other gadget suddenly shutting off. Thanks to the river, thousands of square miles of desert in the southwestern U.S. can stay green, providing food for people across the country. Overall, the Colorado River provides water for roughly 40 million people across the same 7 states it flows through. Basically, it's a river that's a literal lifeline for everything around it. But not everywhere. Look, this is also the Colorado River, or what's left of it, a dead zone that raises just one question. Who killed the life source of the American Southwest? And why? Dams. Hydropower plants are energy facilities that might be hard to build, but they sure make people happy by producing valuable megawatts without any extra hassle. The river flows, spinning the turbine, which spins and generates electricity. No fuel, no worries about the river suddenly running dry, everyone's happy. Now take a look at the area where the 1,450-mile-long Colorado River flows. There's simply no other river around that could support hydroelectric power plants along its course. We're not counting the tributaries. They don't have enough water power to generate serious energy. So people didn't come up with anything fancy. They just lined the whole river from start to finish with dams and power plants. While you may not know about most of them, there's one nearly everyone has heard of, the Hoover Dam. Standing at 726 feet tall and stretching 1,240 feet long, this massive structure generates 2,078.8 megawatts and delivers 4 billion kilowatt-hours annually to nearby states. There's also the lesser-known Glen Canyon Dam, with a capacity of 1,320 megawatts and an annual output of 5 billion kilowatt-hours of energy. In terms of height, it's just a bit shorter than the Hoover Dam at 722 feet, but it's longer, stretching 1,575 feet across. Besides the big ones, there are smaller hydroelectric dams, Parker, Davis, and Grand Valley. Sure, they produce less power, but they definitely play a big role in keeping 7 states along the Colorado River supplied with electricity. Overall, people from the nearby areas get more than 10 billion kilowatt hours a year, which is definitely great, because with that much energy, you can ditch a lot of other sources like coal plants. But you haven't forgotten, right, that we're investigating who killed the Colorado River? Who did this to the river? So dams, they may not be the main culprits, but they certainly have their spot among the factors that negatively affect the river's flow. Why? Well, here we have to try to set aside how helpful dams are and focus on their negative sides. Each dam is literally a wall blocking the river. Water can still flow further, but only through a limited area and only when people allow it. As a result, the river in this area starts turning from a fast-moving stream into a reservoir. Water stays put because its movement is either severely limited or completely stopped. Take a look at what's been created by the massive Hoover Dam. This is Lake Mead, which when fully filled is 118 miles long, 531 feet deep, and covers 247 square miles. It's rightfully called the largest reservoir in the U.S., holding 8.5 trillion gallons of water. Here's Lake Powell, which was formed by the Glen Canyon Dam. It holds 8 trillion gallons of water, second in size only to Lake Mead. Reservoirs are a good thing, I guess, because it's much easier to take water from them than from a flowing river. Plus, there's the possibility to develop tourism. These lakes also help prevent flooding downstream. But, a big but, the water in them evaporates much faster than when it's in a fast-moving stream. There are 15 dams right on the riverbed, and the temperature in this area is high, so evaporation reaches huge levels. For example, according to the analysis by the Southern Nevada Water Authority, the Colorado River loses about 475 billion gallons of water annually due to evaporation and related factors. That's more than the entire state of Utah takes from the river each year. And according to another study published in Water Resources Research, about 10 trillion gallons of water evaporated from the entire Colorado Basin between 2000 and 2021. So during that time, the 7 states using the river have ended up short by more than one fully filled Lake Mead. Nature certainly pulls off the most incredible heists. So it's hardly surprising that the Colorado River turned into something like this in one spot. This, by the way, is the river's delta, the point where the river flows into the Gulf of California, or the Sea of Cortez. It's located in Mexico, right after all those dams that generate a huge amount of energy. But this is only the start of the list of river killers. There are more serious reasons ahead, which is why the Mexican part of the Colorado is just a shadow of the once mighty stream of water coming down from the Rocky Mountains. Imperial Valley. In the southern part of California, there's very little vegetation. That's just how it is. No one's surprised by the high temperatures or the fact that the region is one of the driest in the world. No one here will be shocked that rain dripping from the sky is a rarity. The average annual rainfall barely reaches 3 inches. In short, it's a lifeless area. By the way, these are shots from Southern California. Right next to the desert areas, there's a ton of greenery, and it's located where cacti used to grow. I bet you figured out what made this transformation possible. Of course, it's thanks to the Colorado River. Once enterprising Americans figured it out, it never gets cold here. The growing season lasts all year, meaning plants can bloom and smell all year long. So why not make the area green? And they did. They built a 79-mile canal from Colorado and called it the All-American. About 1 trillion gallons of water flow through it every year, and all of it's used for irrigating more than 772 square miles of land. Of course, one channel wasn't enough to distribute the water, so a vast system of waterways was built, stretching 1,430 miles, with 1,120 miles of pipelines, dams, and everything else needed to irrigate such a large area. Thanks to this system, vegetables, fruits, cotton, and grain are grown in the desert. As a result, the Imperial Valley generates $1 billion annually, and the produce here can be found at breakfast, lunch, and dinner in any U.S. state or even abroad. Everything looks great again, just like with the dams. A blooming valley in the middle of a desert area that provided jobs for a huge number of people, and now it's even possible to live in this region. The population of the county is just shy of 200,000 people. But water has to come from somewhere, and it's taken from the Colorado River through that very All-American Canal. And water's needed in large amounts. Every year, Imperial Valley pulls 1.4 trillion gallons of water from the river. Overall, it makes sense, since 772 miles of farmland need to be irrigated, but such a huge demand also comes from what people grow in the valley as well as how they do it. There are plants that need relatively little water. For example, about 43,000 square feet of dry beans require 490,000 gallons of water to grow. Sugar beets grown on the same area will need 980,000 gallons of water. And then there's alfalfa, which isn't eaten by humans but is happily consumed by livestock. This plant requires a whopping 1.63 million gallons of water on a 43,000 square foot plot. Actually, a lot of people are against growing alfalfa in the Imperial Valley because humans don't consume it. But in 2021, almost 20% of the alfalfa from the Western Territories, including the Imperial Valley, was shipped abroad, for instance to China. So geopolitics, international trade, and all that important government stuff really come into play here. Now let's take a look at how crops are grown. In the valley, there's a common method of irrigation known by many names, but we'll call it flood irrigation. This method essentially means flooding the area almost entirely. It's simple and efficient, but the water consumption is enormous. Sure, irrigation like this is often controlled, but we're not sure many people are worried about how much water is being dumped for irrigation. By the way, we can't help but mention this amazing fact about water consumption in the Imperial Valley. Can you guess who might use 22 billion gallons of water from the Colorado River? No, it's not a group of farms, an agribusiness, or anything like that. In 2022, just one family took that much water to irrigate almost 31 miles of their farmland. That's the same amount of water allocated to the city of Scottsdale, Arizona. And here we're talking about just one family. So to really understand how much water is used by agricultural lands in Southern California, take a look here. Their consumption is higher than, for example, Arizona and Utah. In general, this is a very important region. One you could easily call a key reason why the Mexican section of the Colorado River is pretty much dead. Central Arizona Project. Arizona is the third biggest water consumer from the Colorado River, after Colorado and California. Why? Simply because of the Central Arizona Project, or CAP for short. In line with the project, a diversion canal was dug with a length of 336 miles, which was complemented by a system of aqueducts, tunnels, pumping stations, and pipelines. Of course, the primary goal of the CAP was to provide drinking water for the residents of central and southern Arizona, where finding something decent to quench their thirst was once a big problem. As a result, around 40% of the state's population gets water from the Colorado River. Nearly 40% of the water in Phoenix, the state's largest city, comes from the long-suffering river. Tucson, Arizona's second-largest city, also gets a lot of its water from the Colorado River. Every year, CAP takes 449 billion gallons of water from the Colorado River, and that amount clearly suggests that the project wasn't just designed for the locals to drink. Of course, a huge amount of water goes into agriculture. Besides, a lot of water from the Colorado River just gets lost. According to some reports, 5.2 billion gallons disappear due to evaporation, and another 2.9 billion gallons are lost due to seepage or leaks. All of this makes Arizona and its project yet another reason why the delta of the river has been literally destroyed. Delta. And now a bit of history. In the 19th century, the flow of the Colorado River in Mexico was over 317,000 gallons per second. Then came the building of canals, land greening, dam construction, and in Mexico, the Colorado River's flow dropped to about 43,000 gallons per second. The final blow was the building of the Glen Canyon Dam, followed by the Morelos Dam, the last blocking point. After that, the river's flow dropped to 2,200 gallons per second, and since 1998, the Colorado River in this area looks like this. The flow is down to around 132 gallons per second. There's no outlet to the sea, and there's hardly even a river anymore. Just traces where once there was a strong current. Actually, it wouldn't be accurate to say that the U.S. just blocked all the water of the Colorado River from Mexico. Around 475 billion gallons of water still flows through the border according to the treaty between the countries from 1944. However, due to the recent catastrophic events related to the Colorado River, which we'll talk about later, Mexico's been getting less and less every year. For example, in 2022, the amount dropped by 5%, and in 2023, it fell by 7%. Basically, whether this would be enough to revive the river delta is still an open question, because all the water that crosses the border gets diverted to Mexican agriculture. Through a complex irrigation system, the water reaches cotton, wheat, alfalfa, asparagus, watermelon, and date palms in the vast surrounding desert valley. It's good for the farmers, but the river itself doesn't reach the sea and the delta is dead, which has caused major harm to nature. In the 1980s, 80% of forests and wetlands were lost, which had catastrophic consequences for the flora and fauna. In 2014, during an ecological experiment simulating spring floods, water rushed into the delta, which helped the seeds naturally germinate and increase the bird population by 43%. In fact, Mexico, the U.S., and many organizations worked together to figure out how to restore the river and decided to test how the delta would react this way. There haven't been any stronger water flows since, but they still plan to restore the area. For example, there's Raise the River, an organization focused on bringing life back to a dying delta. Their goal is to restore 3.6 square miles of land that was once thriving. For their efforts, Raise the River has brought together everyone they could and is working on removing invasive plants as well as planting local species. But the most important thing is that the organization has played a key role in organizing water supplies to the delta, which has been happening in recent years. These positive events for the area took place in 2021 and 2022. Water reached the dying delta again in 2024. Until October 3rd, a flow of about 8 billion gallons of water was provided. If things keep going like this, experts say that some ecosystems will really bounce back. The delta will come to life. Plus, some people will get back to the spots where they used to swim, and fishermen will be able to fish again. However, for all this, there needs to be a constant contact between Mexico, the U.S., and environmental groups like Raise the River. But right now, everyone's focused on making sure the Colorado River doesn't end up turning into a desert, with the delta being the last thing on their minds. End of Colorado River. If you search for Colorado River, you often see drying up pop up as a suggestion. In short, yes, while many are working on solving the delta problem, the river is shrinking fast. In 2022, the UN issued a warning that water levels in Lake Mead and Powell, the reservoirs for the massive Hoover and Glen Canyon dams, were at their lowest point ever, dangerously close to reaching Deadpool status. It sure sounds scary, but the reality is even worse, because this status means the water level is so low, it simply can't flow downstream to power hydroelectric plants. For example, here are satellite images of Lake Mead. You can clearly see how the water level changed from 2000 to 2022, And here are the same images from 2022 where you can easily spot how much the lake's level has dropped. The upper edge of the exposed white rock marks where the lake's surface used to be, and if you like numbers, the lake's maximum level in 1983 was at 1,220 feet, but by 2022 it had dropped to 1,050 feet. Here's another striking photo. A boat left stranded where water once was. Or here's an archived photo of the Hoover Dam, followed by a shot from 2022. At that moment, the big question was what to do next. Because if power generation grinds to a halt, it's a catastrophe for tons of people, businesses, and agriculture. Basically for everything in the 7 states dependent on the Colorado River. And from there, it's just a short step to a drinking water crisis. The response was swift. Water usage had to be cut back, especially in California with its Imperial Valley. By 2024, the state recorded its lowest water use since the 1940s, which has raised Lake Mead's water level by 18 feet compared to its 2022 record low. It's not really clear how long you can manage just by cutting back on consumption. Besides, while the lower Colorado River Basin, including California, has reduced its water withdrawals, the upper basin has ended up with lower reservoir levels and a whole bunch of other problems. Cutting down on water usage doesn't mean this approach actually works. Besides, it doesn't do anything to solve another issue: megadroughts. Here's the thing. The Colorado River is partially fed by the snowpack in the Rocky Mountains. It's just 30%, but because of rising temperatures and less snow, the runoff is dropped by as much as 86%. So this problem needs solving somehow. As is often the case with climate issues, we need to cut emissions. However, there's some good news. Many experts are now saying the next 25 years could bring more rain, which might save the Colorado River from drying up. Still, that doesn't change the fact that the river has a lot of problems now and might face even more down the line. The whole thing comes down to bad calculations. A century ago, officials split the water from the Colorado River among 7 states: Arizona, California, Colorado, Nevada, New Mexico, Utah, and Wyoming. The split was based on one super important number: the total amount of water the Colorado could deliver each year. Officials ignored scientists' research and claimed the river could provide about 5 trillion gallons of water a year, but in reality it turned out that the Colorado River has only given about 4.5 trillion gallons of water in the last 500 years. After factoring in the evaporation from the reservoirs formed by the dams, we get roughly 3.9 trillion gallons. Meanwhile, infrastructure was and is being built based on the original numbers, so more water's being diverted than what actually flows into the river. And if the mega drought keeps going, this could lead to much bigger problems. In the end, the Delta, ruined by dams, agriculture, and everything else, will be remembered as the good old days.